Hi, and welcome to part 2 on composite functions. For this part, I'll be looking at when something is not defined over a given domain, and then I'm going to, I guess, change the domain so that it is defined. Now, here, this is my best shot at trying to explain some of this. If it doesn't make sense, I apologise. I might try and explain it to you again in class. You don't necessarily have to understand it, you just need to be able to do it, but it's nice to be able to understand it as well. So here I go. So if I take f of g of x, for example, what's happened to f of g of x? I'll write it down here. F of g of x. Now, there was originally, once upon a time, there was this graph g of x, which was a bunch of x values. But what happens is, once we've subbed in our x values into g of x, they turned out to be y values, because that's what you do. You know, if g of x equals x squared, then you sub in the x values into here, x equals 1, x equals 2, 3, 4, whatever, and they actually become y values. Now, what happened to these, the range, or these y values? Once these y values, because we've actually got a graph inside another graph, those y values actually end up being the domain of my f of x graph. So my x values from my original domain of g of x become y values, because that's what you do. You sub them into x values as x values. They become y values, and then those y values actually become x values of the outside graph, this f of x. They're subbed in as x values. Okay, that's kind of what is happening with a composite function, and so therefore that's why the domain of the whole graph is the domain of the original graph, because those were the original x values that we subbed in. But that's also why, if the range of the middle of the graph, if that's not a subset, or if that's not equal to the domain of the outside graph, then it's like you're actually trying to substitute something into something that doesn't exist. You still with me? So what it means is that we're actually subbing in y values into this as x values, but it doesn't exist somewhere. That's not quite possible. So let me just take an example from back here. Hopefully you still know something of what I'm talking about. The one that wasn't defined, g of f of x, let's just try and look at that. My domain of f of x was all real numbers. So let's just take the x equals 0, for instance, here. So x equals 0, that's possible, correct, for this graph. F of x, when x is 0, that means that y is equal to 0. Okay, and then what I'm doing is I'm taking that y value and I'm substituting that into this one over here as an x value, because it's it was g of f of x. Okay, that thing is there. So I'm actually saying, find x equals 0. That's my original x value, but that becomes y equals 0, and then that is being subbed in here as an x value. But as you can see, y equals 0 into here, it's not y equals 0. It's actually, it turns into x as an x value. That's not possible to sub in 0 into this equation, because the log of 0 doesn't exist. So we have a problem, and that's why it's not defined, because it actually doesn't work. Okay, here's where you tune back in if you got lost along the way. Here's actually how to fix it. Here's how to do it. Okay, if you got lost, you don't really need to understand it, but it's nice to. But here's how to fix it along the way. If you have something that's not defined, then you need to change the domain of the inside graph so that changes the range of the inside graph, so then it fits into the domain of the outside graph. Okay, so we need to change this one over here so that changes this one over here, the range, so that now fits into the domain of my outside graph. Okay, because you can't just change a range, you have to be able to change a domain. So you can't just go back over here, you can't just change this bit, this box here, to make it this box over here. You actually have to start with the start, which is this one here. You start with the domain. Once you change this bit, that bit will then in turn change this bit over here, and then therefore that can fit into this one over here. Still with me? I hope so. Let's give it an example. Okay, so this is the one that I was looking at before. So f of x equals absolute value of x, and g of x is log of x. But where is this thing defined? Because it's defined somewhere, it's just not defined everywhere. So the range of f of x needs to be the same as the domain of g of x. So this bit here, this box, needs to be the same as this box just here. Okay, that's actually a y, but anyway, that box there needs to be the same as this. Okay, so my range of f of x must be the same. Must be x is greater than 0. Okay, it needs to be the same. I know it gets tricky because we're swapping x's and y's, but the range of f of x needs to be y is greater than 0. Okay, so I'm going to change my domain of that original graph so that it changes the range. So I change my domain of f of x so that the range is now greater than 0. So if x is not equal to 0, then the range will be acceptable. If x is not equal to 0, I'll have a big dot here, and all of the other values will exist, but that dot won't be there. So therefore, my range is now real positive numbers. Or another way of writing that is x. Sorry, we're dealing with range, aren't we? Y is greater than 0. So if I now draw up this little table again, showing all the information that I have, my domain of my inside graph, I changed that now to be all real numbers except for 0. Okay, that meant that changed my range of that inside graph to become y is greater than 0 now. And my domain of my outside graph I haven't changed. That's still x is greater than 0 and the ranges are. But now, as you can see, the range of the inside graph is now a subset of the domain of the outside graph. So therefore, the graph works. Where does the graph work? Well, that's the big question. The graph works for the original domain of the inside. Okay, so I changed the inside domain. That changed the inside range. That now fit into the outside domain, and the graph worked. So the domain overall is the domain of the inside graph. Okay, and finally I have this graph works, and it will actually be looking like this: log of absolute value of x when x is all real numbers except for 0, because that's the domain of the inside. That was so clear in my head. I hope that works for you guys as well. I might just do one more example in another video just so that you can get the hang of it again. But as I say, even if you don't understand it, if you're able to do it, that's better than nothing. So at least you can do some of the algebra of it, but it's also good to be able to do some of this as well. So stay tuned for one more video, and then you can have a go at some of the exercises. Thanks for listening.